to episode 126 of 𝗦𝗢𝗡𝗪. I'm your host, Connor, and I'm with my temporary co-host, promoted because he is the only panelist, which we will be talking about a little bit more. We're going to go around and, I guess, do brief introductions, because that's just the way we've always done things, and then we'll hop into a couple announcements. So over to Adam.
Right. So two things coming up. The first one is the deadline for the APL Forge submission. It's the 22nd of June. So it's just coming up soon, in a week. So that's the sort of competition where you can submit projects in or for APL. And then we have a committee of people looking at that, and you can win a prize and a trip to the upcoming APL user meeting, Dialogue APL user meeting, which is going to be in Eastbourne on the 12th to the 16th of October. Speaking of that, its registration has begun, and well, you can't see the full schedule yet, but you can see what the workshops are going to be like, and the schedule for that. So you can have a look.
All right. I think we technically skipped your brief introduction and went straight into announcements, but that's all right.
They know me by now. They know me.
I actually also have a, it's not an announcement, but it is a call to action of sorts. So whether you're listening to this live or you're listening to this on the audio recording later, we are looking to, and I know that there are a handful of folks that have reached out via email or Twitter DM or Discord. I have the people in mind that I'm thinking about that DM'd me on those platforms, and I think actually maybe one person reached out to us on contact@𝗦𝗢𝗪𝗡𝗏.com about joining us as panelists. So we're looking to grow our team of one panelist team. I mean, Rich might be joining a little bit later. He's in a meeting right now, but just like last time, he might be joining us. If you are interested, because we don't want to miss any of the informal applicants that might have emailed us anytime between, was it November of 2025 and now, send us an email if you're interested. We might be doing something a little bit differently. We might not be having necessarily all permanent panelists. We might just have rotating panelists, so different voices from episode, but you'll hear the same kind of recurring voices. If you're interested, drop us an email at contact@𝗦𝗢𝗪𝗡𝗏.com. If you want, add, one or two or three sentences about why you'd be interested in joining as a panelist and your background, if any, with array languages. You don't necessarily have to have array language experience, and we'll go from there. On top of that, not only are we looking for panelists, but we are looking, hopefully, for someone to not fully replace Bob Terrio, but to replace the part of his job where he would reach out to guests and set up the recording timing schedules for guests, because we have a list of guests we'd like to start bringing on, but Adam and I are both very busy folks, and we thought, seeing as we're growing the team, and a part of that original team was someone that had the time to reach out to guests and set up the schedule of recordings, that'd be fantastic. So if you are not only interested in being a panelist, but would also like to do that, or you're not interested in being a panelist, but for whatever reason you like that kind of managerial, organizational stuff, and you'd like to be involved in kind of setting up who's going to be the next guest and sending out those kinds of emails, also shoot us an email at contact@𝗦𝗢𝗪𝗡𝗏.com, and we'll leave it at that. So if you're interested, shoot us an email, and we will review those over the next 2 weeks to 4 weeks. And then you'll probably hear some announcements on this podcast at some point, and we'll be reaching out to folks in between now and then. With those two announcements plus a call to action out of the way, links, as always, not for the email, but for the two things that Adam mentioned, will be in the show notes. We have another episode of Adam Live Codes and Connor Learns Things. Once again, we're going to be solving a couple Perl Weekly Challenge problems. Well, we're guaranteed we'll solve one. I think the first one's a little bit easier, and I actually don't have too much that I'm looking forward to like pick up a little tip or a trick here. Although I'm sure I will in watching Adam do it. I'm more interested in getting to the second one, but we'll see. Maybe the first one will be more interesting than I anticipate, and it'll take up the whole one, and then we'll have to kick down the road the second one. So, I mean, I'm not sure if you want to screen share, Adam, seeing as you're going to be live coding in a sec, and then we can describe the, what do you call it, problem statement, which I'm now trying to see. Well, yeah, we'll let you live. Or are you gonna screen share?
I can, but I don't even know what the problem is yet, so I'm sort of scared here.
He hasn't. Well, yeah. So, I mean, I linked it in the chat, and I guess actually that's probably everyone can see on the live stream. Actually, it says Raycast 126 and Pro Weekly Challenge 377. So if I close this, no one can see that anymore. Anyways, we'll wait for Adam to screen share, and I believe the problem has something to do with substrings.
Okay, well, I guess I can start sharing my screen and see if I open the right window here. Let's see.
Problem is I've got like 1,000 Chrome tabs.
Well, let's see. So I believe this is the right page, 377. That's what you said.
Yes.
Okay. Let's see if I can figure out how to read this.
You got to scroll down all the way past this nonsense. They always do like recaps.
What is this?
Then they do stats.
Okay.
And then they do. There you go.
Task 1. Here you go. Okay. I guess we can make this full screen. I need to see this. You're given a string. Great. Write a script to find whether any substring of length 2 is also present in the reverse of the given string. Okay.
So pretty straightforward. The problem is called reverse existence. You're given a string. The first example was ABCBA, I think. And the problem's asking you to return a Boolean, a 1 or a 0, based on whether any substring of length 2 has its reverse in the string as well. So for the first example, AB exists as BA at the end of the string. And in general, any palindrome is going to return true by definition. And
unless it only has one character.
I guess I was about to say, unless if you have a one-character string. But then the string in example 3, ABCD, is going to return false because it does not have... I guess by definition, you're also going to need duplicate characters. Not that we're going to.
If it has duplicate characters, then yeah, of course. So, I mean, maybe there's a better way to do it, but I think very simple. If we start by looking at the pairs that are there, and then we can look at the pairs reversed, right, and check if any is a member. So these are those the reversed, and we want to check if there are members of itself. So they're all members, right? Because this is a palindrome like this. So that's obvious. A, B, C, D. All members. But if we want to do something where they're not all members, maybe you have like a normal test. Banana, sure. Okay.
Well, I was going to say ABCD should return all 0.
Oh, no, this is a mistake. This is a mistake. The reason is that I don't want to reverse the list of strings. I want to reverse each in the list of strings. Okay, so there we go. So ABCD. And then none of these are, right? And banana. These are, right? So all we need to do is we want to see if there are any. So that will do it. This is not a proper function. It's just a sequence of operations, but we can just wrap it. So this is how I'll do it initially, but I think we can be maybe slightly more clever.
I was going to say this is already better than what I did.
Okay.
What? Let me find the.
But is it clear how it works? Everything, the structure of it.
Why did I? I guess that's the thing is I don't have my membership and find and the epsilon functions, I guess committed, and so I always do that thing where you like, just try
Yeah,
one,
make
try
a
another
mask,
one.
and yeah.
But I
So
I have the
another
same thing, but I guess I did it one by one. I didn't so like I have like a reverse of each one at a time. It's so much more complicated. This
So
is
we have a question in the chat if it's guaranteed to be only 2 letters. But yes, that's the problem.
yeah.
Just find the substring you link to. So this would be easy. Here's another thing we can do. We could put a swap here, which is the same thing as giving a -2 over here, but that doesn't really matter for now. And that gives us also the reversed substrings. So we could look at whether these are members, right? So we can actually make it a little train. This is excessive work because we're making, I mean, it doesn't really matter. We're making the substrings twice. So we can say, are the normal order linked to substrings members of the reverse order linked to substrings? And then we can write that. So that's, I mean, it's just a different way of stating it. Whether we generate them from the outside in a different way doesn't really make a difference.
Yeah, this is well, like I said at the beginning, probably I was gonna learn something even though I wasn't expecting this to be the problem. But yeah, this I don't know why, because I guess this is the membership glyph, and if you've got substrings against substrings, I guess that's the thing, is I didn't think to search the substrings in the reverse substrings. I kept substrings versus a string. And so then
I guess you could do that. Yeah.
Yeah, but it's a way worse idea. But if you do that, it's a little bit trickier.
If you do it like this, right? And then for each one of these, we want to find out if it's a member or if it's found in the entire string. Oops, what a mistake I make here. Oh, missing the argument. And we don't need an each. We need the each over here. There you go. So now we say for each, we get a mask of the places where it appears, which would be more interesting if we're actually looking for specific places where specific substrings are found, but we're not. Right. So it doesn't really matter. So all we need to do is see if there's anyone in here anywhere, which
there's
we're good.
A couple different ways you can do, yeah.
I mean, just like that, we'll do it.
That was not one of the ones I was thinking of. I was thinking of or ravel or.
Yeah, we also know they're the same length, so I guess we could even do it with a rank. But I mean, there are many different ways of doing it. They're not especially attractive. We're looking way too much here. I mean,
so I have a question about why did you default to enclosing the original string versus, I guess when I did it,
I could have bound it like this instead.
Yeah, that's what I did.
Slightly neater.
And this is why I wanted to do the problem
looks funny.
In the first place, is because in order to, if this is the way that you originally spell it, which is what I did, minus the find, I did a or reduce. In order to go from that to tacit, you end up having to kind of do the backflip in order to get what you originally put, which is enclosing the string in order to put it in a form.
Yeah, because you can't do this. Yeah.
It's one worth getting to hear from you. Why did you do the enclose original string first? And probably we should slow down a bit to explain this to the audio only listener. And then also too, this is like a trick that I learned. I considered it a trick at one point. Or wait, I actually don't. I don't actually understand what you've done now. So you've avoided, or no? You have
commuted, because it's a fork over here, an AGH fork on the left. So that means it has to be parenthesized or bound, but we can't bind the two to a derived function anyway on the left, so we have to parenthesize anyway. So then I just immediately went for, okay, I'll swap the arguments, and that's what I did here.
Yeah,
So we
that's
get the
really
AGH4
hard
right.
to, because you're doing
Yeah,
each on the dyadic and then a commute in order to do the enclose. That's
yeah.
if you're seeing that for the first time and trying to parse that,
Yeah.
it's a bit tricky. But yeah, walk us through. So is why you reached for the enclosed first, and then this kind of trick in general.
I don't know if we call it more functional, but like I prefer keeping things in their right places instead of composing them. Composing with a, well, it's not called composition, it's called binding. Binding a right argument is somewhat messy because it converts a dyadic function to a monetic function with the remaining argument slot being on the left. But being that it's now a derived monetic function, that argument goes on the right. So maybe that's a bit complicated to in this context, but let's take minus, for example. So if you write like 10 𝗏 minus, that's a monetic function. It's pretty easy to understand. It's 10 minus. But if instead we wanted to write the minus 10 function, right? So this takes an argument over here. So it's 10 minus 100, negative 90. If we wanted to write the minus 10 function, which we had to parenthesize in application, but that's not so important. And then the argument over here, then notice that this argument, which appears to the right, the argument to the minus 10 function, actually becomes the left argument to minus, even though there's no explicit swapping going on. That means things are jumping around a bit. I prefer right arguments to remain right arguments, left arguments to remain left arguments, or being explicit about the swapping, which we can do with the commute operator. So that might be one reason why I prefer to enclose on the right instead of binding. But sometimes I'll do it.
That makes sense. And then, well,
it's also not a very meaningful function. And if you bind an argument, you sort of want the derived function to be meaningful. But what is the find in omega function? This is a weird thing. It's like look for ones. That's a meaningful function, but not look in something.
Right. And then explain. So that makes sense. Walk people through this enclosing a string or a vector and then performing the dyadic operation each time, because a lot of times, especially when you have the original pattern where you're trying to bind, partially apply an argument to a dyadic function in order to apply something over, like, it took me a while just to stumble into this kind of pattern. Whereas, like, if you want to turn that into tacit, the pattern is to enclose it and then do some dyadic operation each.
Yeah.
Like, one, is there like documentation somewhere to point people at this? And even if not, like, what's the path? Is the path to discovering this just that is the more and more you program an APL, at some point you will kind of stumble into this pattern, and then you'll, if you're lucky, store it in your vault of ways to solve things tacitly? Or
so I don't know. We can look at the documentation for it, but I think it is a problem people have with the each operator, is that especially if they come from another programming background and they think each is just, oh, that's just my map, but it's not. Then they expect a single thing on the left and multiple things on the right, expect it to map over. So if we take like ABC and we want to concatenate just for ease of usage here with XYZ, so the actual mapping, which really means stepping over elements, right, with sort of iterating, appears on both sides. So it's a double map. This usually would have to write this either with explicit iterator counter that you then index in other languages, or you have to do a single map that includes the iterator and then use a single indexing for the other arguments, which makes it asymmetric. But each is completely symmetric in the APL. So the way it works is that we have got the scalar extension. We can have a single element. That's a bad example. That maps to both, to all the elements of the other argument, and we can start off with many on the left and have a single thing on the right, and it will map the other way. We can even have a single on both sides. That's also allowed. Then we get an enclosed result. So the way to say the one-to-many is a solved problem. So if we want one side to be considered one, you sort of want to reduce the problem to that state. So we need to change this vector that's on one side, or any array really, to a scalar, and we do that by enclosure. Okay, so each actually opens up enclosures. It actually digs into an array, which can be a little bit hard to spot when you're dealing with simple arrays because we've got this floating array model. But really, it's reducing the depth of the arguments by one. And what happens here with the each, where we've got an array with multiple elements on the left and a single array that contains multiple elements on the right, is that we reduce the enclosure level by one on both sides. So we take the first element of the array on the left, and then there's only a single element on the right. So we take that element and disclose that as well, which reveals the entire array that's inside. And then we do the same thing with the second element on the left and open up on the right and gives it the entire array. That's why effectively it becomes a many on the left to one on the right. I know the K language has like explicit separate each operators or adverbs, like each left and each right. But in APL, that's because they don't have, because they don't have the concept of an enclosure, a scalar enclosure. You can only do one element lists. So it's a whole different way of doing things. We can write an each left, each right operator in APL, but it's easy to do it like this. And so too, we can, so this maps each element on the left to the entire array on the right. And similarly, we can do an enclose the array on the left and concatenate each to an unenclosed array on the right, and that maps it the other way. So these are the two different types of eaches. And then again, as before, we can just do a simple each with no enclosures, and that pairs up the individual elements. It sort of hints at an operator that's missing, the depth operator, which PQN has. I think that was in my initiative. J actually has it, called the level at operator or adverb, but isn't much used there because J is much more about dealing with higher rank than deeper depth. And then the completely equivalent thing is we can bind. So the binding, this long left scope of operators. So the each here sees, if we write quote ABC quote jot, comma each. So the each sees the quote ABC quote jot, comma as a single thing. It's a single derived magnetic function that's applied to each element on the right. And that's why it has that effect of concatenating the entire left side, because it's been bound into the function to each element on the right. The other way is interesting because we can't just put a jot on the other side. That doesn't make sense syntactically. So we do want the jot in this position immediately to the right of the concatenation function, but we have to put the operand to the bind operator immediately next to that as well. And then some people end up, especially when they're new to APL, writing something like this, where we have got a left argument and then comma jot, right argument each. But that's not right, of course, because the comma jot, right argument each is a single derived magnetic function. And it takes a single argument, which is on the right. So the ABC now needs to move over to the right to get that effect we had before, that's the sort of thing that can be confusing. Positionally on the line of code, the left argument is on the right and the right argument is on the left.
Yeah, at least for me though, when I was learning APL, this was easier to get to, because well, I guess it just depends on the order that you learn things. But like for me, coming from Haskell, where partial application and like binding is very common, it maps like very easily to APL, right? You have your bind operator, and you can partially apply something on the left or right. And so if you know that you're trying to fix something, and you're trying to apply that unary operation, it's easier to, without learning the, full depth or like comprehensively understanding what each is doing and how if you're adjusting its, the with enclose, like that's an extra thing that you need to learn, and you can get to what's on the screen right now just partially applying something on the right, putting that on the left, and then eaching it over whatever you need to. And so that was typically the way that I would do things until I actually don't know how. I guess one day I just was messing around, and then I was like, oh yeah, if you enclose it, I guess that kind of makes sense. You're otherwise, would have I ever explained that what was happening is that the each was reducing the depth by 1, and I don't think that's how I would have ever explained it. I think I just knew it as like a little idiom that you enclose something on the right, and then it'll apply over the whole thing.
So I mean, I guess J is a bit more formal about things. In a way, it's good, but I think pragmatically speaking, it just comes in your way more often than it does your service. So there in J, they don't have each primitive, but they do have an each like standard library word, and it's all it is under disclose. But the under they have 2 different types of compositional operators. The close and wide. I don't remember what the other word is. Application. And so what it does is it does an operation, but on each element or on each cell, it does some application, and then it applies the function and it joins everything back together again. So really, we can see each as being a rank 0 under disclose thing. So or well, we say all the way around. It's disclose on rank 0. So if we think about it, we can try to define the dyadic each, but let's just do it for a single thing. Well, actually, let's make it monadic because it doesn't really matter. The pattern is the same. So let's make the each operator, and all it does is we have an argument, and we have a function that we are applying rank 0. That's on every element, if you want. But before we apply the function, we're going to apply a disclose first, if you want. But since this rank 0 means there will only be 1 element, so there's no difference between a mix and a first. They just disclose. And then when we are done, then we package it down again with an enclose. So this is sort of an under. We don't have the under operator yet, right? So, but we are disclosing, applying the function, and enclosing, and then that gets collected into the argument. So we can see here, if you say A, B, C, D, E, F, so we can do a reverse each, and reverse with our fancy new operator, each gives the same result. This is really the definition of each. And the dyadic form is exactly the same, except instead of applying with a function atop disclose, it would be a function over disclose. So we're just applying pre-processing to both sides. That's the whole definition of it. Then we need an alpha over here. So now you can see that it's explicit, that this disclosing, and then you can also see why enclosing sort of negates the pre-processing of that side. If we enclosed omega here, then when we apply rank 0 on omega, that's the entire array because it's enclosed, so that's a scalar, that's the whole thing. So that doesn't matter on the right. On the left, of course, if we have multiple elements, it will go into each element. And then we disclose it, which it's just a single enclosure. So that gives us what's inside it. And on the left, it does its thing on each element, and so on. Does that make sense?
It does, and maybe I will take the time to add chapters to this YouTube live stream after it's done recording, and I'll call this each deep dive and tacit tips or something like that. And so then we can just point people to the timestamp whenever they have questions about, because this is
actually
very
write
useful.
TC as a trace operator in the defense workspace that draws out. Let's turn off boxing here. It will be very flooded. It draws out on the screen the steps of computation wherever we insert it. So it's just a magnetic operator. We can attach it to any function. So if we attach it to every function, then we can see exactly what's going on. So here, this function, the disclose, and we'll put a TC on that. And the main function, we can put a TC on that. And the enclose, we can put a TC on that. Okay. So we're redefining our each like that. And now we're doing what we did before. ABC, comma, each. So we can see here that the first thing it does is disclosing the X gives us X. Disclosing the A gives us the A. There's not much there to do. We're picking those, right? And then we concatenating A and X together. That gives us part of the result. And then we take the next step. We enclose that result, and that goes into our result array. And then we take the next one, the Y's and the B's, and so on. The whole step through. Now, if we enclose here, we can't really see much, but we'll see a little bit of the spacing will be increased. So we can see that there's extra spacing here that sort of indicates that it's enclosed. So we're disclosing that, and that gives us the unpackaged form. So it's just negation of that enclose. The rest of it is sort of the same.
Very neat. All right. Well, I mean, we've spent 30 minutes on the first problem. And I think we've.
Well, we're not quite yet. There are other ways to do it, because this is the pro bigger problem. So we got to solve this with regex, man. Otherwise, it's
all right. Well, we'll let you see. We'll time box the regex solution to how quickly can you do it?
I think I can do it pretty quickly, because we want the one letter followed by another letter, which no obscene thoughts here, and then we want any sequence of characters followed by the second one and then the first one, right? This would mean if this matches anywhere, then the answer is true. Right? So A, B, C, D shouldn't match any. We've got nothing. A, B, C, B, A. We found that, right? So that's the first two and the last two, but we're not actually interested in whether or not what the answer is here. We just want to know if there is such a thing. And banana, we found anana, right? So we found an followed by something followed by na. There might be multiple of them, but it doesn't matter, because the first one is going to find, well, is enough. So if you write like a, b, b, a, and x, y, y, x, we'll find two. All we need to know is how many are there, and then we could take the sign of that, or see if is one greater than is it more or equal to one? So that would be the solution as well.
That was very fast, and still not as short as the APL though.
Oh no, I know.
Well, I mean, technically it is APL, but not your original solution. Asher in the chat,
Curl in APL,
which I believe is your coworker, says that he just posted a bunch of wacky ways to do the original problem, ordered from clear to short. But I think
I can't see them.
I think YouTube is eating all of those solutions.
Actually,
So
you can just send them to me in normal chat,
I
and
was gonna say either send them to Adam, but in general, that's only a good solution for viewers that know how to send them to you. So I'm going to array cast GitHub repo, and I'm creating a new chat, and I guess we'll just call these. What do we do? We call this. I guess it is a podcast episode.
so here are Ash's solutions. So what's going on here is he's doing an outer product of the array with itself, and then he's looking at whether we have any diagonal matches and any full matches. That would be if they are right. So any diagonal matches, that's if we have a reversal, and any full matches would be if we have duplicates, I believe. And so and he flattens that, and and find out if there's any anyone in that. Seems a bit overkill to me, but sure. This is a similar, that's exactly the same, just instead of looking for these patterns, then he's just doing rotations to match things up, and then seeing if there are any such patterns. He's still more of this idea, finding the indices and seeing if there are any indices that are off by one from each other. Okay, that's what you mean by wacky. Yeah, I'd agree with him that wacky is a good description of these. Here.
And if other folks have solutions, because last time we got a very cool 𝗦𝗛𝗢𝗆 solution at the tail end. But yeah, J, BQN, any array languages, Tiny Apple, feel free to, you can try posting them in the YouTube chat. And then if it doesn't work there, you can post them in the GitHub discussion, link to Raycast. All right, let's move on. Thank you for those submissions, Asher. Those are very cool. I am very interested to see Adam solve this, because my solution to this was pretty terrible, and he already improved upon the first problem, so he's almost guaranteed to improve upon the second problem. The question is, how nice will it end up being? Time will tell. And the problem statement is prefix suffix. Write a script to find if two strings in a given array, which is an array of strings, such that to find if two strings in that array of strings.
So there are only two strings in the array of strings.
No, right? No. There are multiple strings, but you're looking for two strings within the array of strings, where string 1 is a prefix and suffix of string 2.
Oh, and okay. I see.
You perform that operation.
So this is a bad formulation. Right? It says write a script to find statement. If the two strings, if there are two strings, string 1 and string 2, such that, right? So string 1 is a prefix and suffix of string 2. Return the total count of such pairs. Okay, so I guess the easiest thing is, I mean, we could do fancy stuff for performance. We're looking at the length and sorting out things that would be impossible. But easiest thing is just to do an outer product. Let's start by importing this. Array is _JSON. Go to turn JSON this off. Okay, so we've got our array. Maybe we should turn boxing on again. Box on. Okay, so we've got our strings here. And then we want to find out how many are prefixes and suffixes of each other. So first we have to figure out what it means, a prefix and a suffix. So I think we could do a find and look at the beginning, at the end, whether there's a 1, but I think it's easier to just do a reversal. So let's say these are again sort of funny examples. But okay, let's take ABA. That's bad example again. Okay, let's do AB and do ab x ab. right? So here, this is a prefix and a suffix. So for prefix, I like to compose things like this. So it's the no, it's not even that. It's the first, sorry. The first of the find. That is the prefix function. That means the left argument is a prefix of the right argument. It's technically speaking on lots of unnecessary work, but hopefully one day, if my colleagues will do their job right, this will be optimized and it will stop looking like this composition, or even with a thunk or something, it will stop looking after the first element, because it will never return true otherwise, because we throw away everything but the first element. But this is the first, right? Now for suffix, the easiest thing to check is whether this in reverse appears at the end over here. Right? So we can just do that with an over reverse. Right? So if we say make this AC, it'll say no there, right? So we need to apply this function twice. One is with the over. We can't factor that out because it's really two different sets of data it's working on. So if you want to make sure that both of these are true, we write first at top find, and first at top find over reverse. So this is the this means that the condition here has been met, and then we want to do this as an outer product on all the array of strings. So that's this. Now they say the result is 4 here, but of course there's a diagonal going down here, so that's a bit of a problem, right? Because they don't count duplicates, right? You can't say the string 1 is both a suffix and a prefix of itself. And but I suppose they do say that well, an interesting thing is, what if it's a complete match as well? If they have the same length and if they're duplicates in
There
here,
is
they
an
don't say anything about
example
that.
below that
Yeah.
I think has that.
Let's see. No, this one. Yeah.
Yeah.
The 1. Okay. That is interesting as well, because if you take that example, above, right? So they don't count the duplicates either. I would say that the first above is a prefix and suffix of the second above, and the second above is also a prefix and suffix of the first one, right? But they don't say that either. So apparently what we have to do is we have to mask out half the triangle just in case, and the middle diagonal. So we can do that. So if we look at a masking here, so if we can try to start with this. Oops, sorry, should be this. Right, this is a masking triangle to isolate just the elements that we want in the strictly top right corner. So this would be with the count. We want to tie these together, the top over here. That's our function. And we can join that in here, this and this. So this gives us our matrix. And all we need to do now is count how many ones there are. So we can do that. There are multiple ways to do that, but classic one is the sum of the ravel. That's 4. It looks sort of noisy, but it's fairly readable, especially if you put some spaces in.
That's God mode APL programming, folks, that you just witnessed there. And let's all just have a moment of silence for this beautiful expression that Adam has put on. Rich, what are you doing in the chat? You're supposed to be on this podcast right now.
Join the call, man.
Or is he virtually attending another meeting And
I don't know. He might be in another meeting, but secretly looking at this.
yeah, well, we called him out.
Rich says that it's too tacit.
I disagree. Well, so my first comments is that mine actually isn't too far off. So I mean, I had the prefix idiom, first composed with, or I guess is it find is the name of the glyph?
Yeah.
First composed with find. I missed this over trick. So I think my first thought was what I wanted to do was under, but I guess it doesn't need to be under because I
you
guess
don't need to reverse it at the end. It doesn't matter.
Exactly. So is that a general rule of thumb? So yeah, my for those that are only APLers and not familiar with under. I mean, is everyone familiar with under? Under is like as Adam likes to say, under anesthesia. You apply an operation, and then you do some other operation, and then you apply the reverse if there is a defined one for that. So under reverse. The inverse or reverse of reverse is reverse. Yeah, clip that. Put that in a TikTok. And but in this case, because you are just getting back a scalar, you don't need to reverse the result. And so, yeah, that's my question. Is that a general rule? If you only need to apply an operation and you don't need to worry about like undoing that operation, can you always use over? I guess not really. It's only in the case where you have two arguments. And also, I don't even think under necessarily would have worked for this. Would it?
Oh, under would have worked because the result is a scalar. Reversing a scalar, it doesn't do anything. So
right.
It wouldn't have made a difference.
It's just unnecessary. And so, anyways, that was the first thing that I saw that you did was the over reverse, which is really nice. And then I did something a little bit different. Instead of building up the upper triangular matrix and masking things out, I did let's admit Rich. Look at that. From YouTube comment section to 48 minutes joining guest. Welcome, Rich. We're deep in
thanks for having me.
Pearl Weekly 377. And now you're here to rain on our tacit parade.
Look, all I'm saying is, look at that. A top abomination, a top a nation.
A top a nation.
Shots fired.
Let me tell you, this line of code is going to get more people into APL than this like JavaScript looking like everything's got a variable name. That's my pitch.
I said it was too tacit. I didn't say you should name every part of it and then compose.
And also too, look at him not aligning these arrows.
I could go back and fix that in post, or whatever you want to call it. Is it if this helps you?
ArrayBox does it automatically.
But
yeah, while Adam is still typing this out,
ArrayBox does multi-line.
It does a little bit.
Oh, okay.
And but the thing, I was saying that the thing that Adam did, where he was building up the upper triangular matrix and then masking things out. Instead of doing that, I did like and I don't know if this is an idiom, but it's a pattern that I use sometimes, where you get an iota sequence, you rotate your original array of strings by your iota sequence, and then you perform an operation where you have, one string versus the rest of the string. So kind of like the head-tail trick, if you're familiar with Haskell. Which one's better? Pick your poison.
Well, I was wondering when I was watching that, is the description, they often are ambiguous. Is it ambiguous enough to say you could just stick a unique on the inputs and then get the number out?
The description is ambiguous enough, but I think
but it's not enough
the examples that is not going to end up working.
Yeah, right. Unique might not work. It's just that it doesn't. Yeah, I don't know. I don't know about this thing. They say there's only one.
And we do things with themselves.
Yeah, we do things with ourselves, so they should count it. Yeah, I think that will work. But we also, it's not enough because this will. You still need to take them away from themselves. I mean, so you still need to do something about the diagonal. So
yeah.
Certainly that's not going to be enough, right? Because even if we take the first one, then we said like everything in every string gets a match on its own because it's its own prefix and suffix.
Yeah.
Right. So therefore, taking away the uniques is not going to, yeah. So you have to get rid of the diagonal. Getting rid of the diagonal, you might as well just get rid of the duplicates with it doing top right instead of diagonal. Right? It's a matter of switching this for an equal sign. So that doesn't really help. But maybe this is more readable, and we could even define this as a function and then apply it at the end. It's a possibility.
I really just once you've got that many tops, it's a defen.
No, but it doesn't really help because if you go back to this, you're saying you got lots of tops. Let's try to see what it looks like as a defen then.
So yeah, this
you don't have to defen it all.
This
like
is
that.
The,
okay, that you're the.
So here, right this one, right?
The far right outer product. You know, I'd leave that.
You leave that. So this is a defen, and then this. I mean. Okay, you're going to compare this with this, you're saying?
Yeah, in so much as an argument that has been made many times by many people that here you can sort of see plainly what bits are applied monadically and to the argument, whereas with
if we put a little bit of spacing like this,
well, meh.
No.
No, I still think the defense just a bit more at a glance.
I mean,
but you know, this is a very controversial topic.
Well, I was going to say we can dedicate the last 38 minutes of episode 126 to once again how much tacit is too tacit, because we've got. I mean, the audio listener is just being like, "What are they talking about?" They're just all like, "What about And we've got 3 solutions. We at one point had 4 if you remove the spaces from the original tacit. And there's a plane flying above me right now. I'm not sure if that's getting picked up. But, you know, the first one on screen is the most tacit. It's going to, for those that like, is the most explicit. For those that like tacit programming, it's going to break your heart because the 2-character, 3 if you're using the compose glyph, has been named prefix, which is 6 characters, you know, a few more if you include the spaces and the assignment. And then it's Omnifix for looking at the prefix.
Oh, it is still completely tacit up until the last line. It's just that it's the composed functions. Adam, if you're talking, you're muted, or
am I? No, Adam. If Adam's talking, yes, you software muted yourself, which probably just was his headphones.
Microphone cutting out.
Right, this is functional programming people of this sort of thing. You know, compose your functions into new named functions and then recompose those functions.
Can you hear me?
Yeah, I can hear you, Adam. You sound good now.
Yeah, so I'm saying, that it's sort of, what's the point of making it verbose and readable when you could take the time to slowly go through, if it's slow, right, to go through these parts. I'm not saying you should remove all the spacing. I think the spacing here can help a little bit to see the structure, but there's like, it does what it says on the tin, right? This, what do you mean by ones? It's ambiguous, but this is completely unambiguous, at least if you know that it's a monadic context. And the same thing here, like, okay, the top right corner, I guess that's works as a name for it, although
it's not really what it's for, is it, though? It's a deduplication. It's a
in this case,
but that's not ourselves. So exactly, you want to name things.
But this, I can read plainly. Like this sort of construct is so common that I'll instantly recognize it. Maybe replace some of these with jots instead if you want, but it's the same thing.
Right, but I'd argue. Well, again,
and this one as well. This one is the tough one, right? This one is slightly harder to read.
I didn't even get to finish describing in an audible way what all of the things look like. Is it even possible?
Yeah. I mean, so the descriptions of them were, and I guess, well, that's a good point. Is that I said the most explicit, but really that is, Rich was correct to point out that technically the first 4 lines where you're assigning names to components of the full tacit expression, that's all tacit. It's just naming. What do you technically call that?
I mean, that's very. If you look at any of the defins workspace, defins.dialog.com, look at the code in there. It's very that flavor. It's name a line as a definition of a thing, and then compose all the definitions or put all the definitions together into the final answer. Which is, and it was very much inspired by functional programming, that way of writing stuff. Yeah. The pure symbol thing is slightly more controversial, if anything.
So we have a comment from the unpronounceable participant name in the chat saying that the tacit code is unambiguous if you know the arity, but with hardware keeping track of all their tops here.
That's what I'm saying.
But actually, a tops tell you what the arity is. If you have a top, you know that whatever's on the left is called monadically. There's no other way. So if you go up and read,
maybe I'm just,
you know that this plus
I'm not
is not a pairwise plus, right? And you know that this outer product here is monadic, and because of that at top,
and
you know that here.
Wrong. Yeah.
So all of these, the same thing goes here. You know that.
Okay, but you have to read several of those to figure that out, and each piece, and it's not. Yeah, and it's like in the fork, you've got some extra noise to detangle between the tops that are either side of the and, whereas the omega, like that's one omega, and then the rest just reads as, that just passes as APL.
Yeah.
So you've got one indicator there saying this is monadic, whereas in your like a top count, a top outer product.
So maybe some kind of compromise thing where we'll just define the omnifix immediately. We say this is what the solution asks for, right? We really it's defining this term of omnifix. So we're saying omnifix is, space it out nicely. Over here, this, and what we want is then the rest of this. Right? These are some qualifications. How about that?
Oh, I see that array box kind of link.
Open my link up, Adam. I wanted to see how crazy it looks.
Okay, I mean, I'll say to that respelling that my problem wasn't with the omnifix side of it. It was the other side of it that I'm not a fan of. This is quite interesting that array box only, can deconstruct.
And the thing is
a tacit function. It can't do this with a defin.
If you go to the parenthesized component and you just select that and then you go Shift Enter, it'll zoom in on that. And then I didn't add this feature. If you go and hover over each of the glyphs in there, like a user went and added this, and so
ooh, that's so nice.
Yeah,
love it.
Anyways, like I'm not saying this is an argument for one versus the other.
No, this is a tool to help you get over the deficiency.
Yeah.
That it's
that you call it efficiency, but I'm saying a dictionary is a tool to help you get over the deficiency of the language that the words
too many words.
don't hold on. The words
too many
the words in English, for example, do not carry their own meaning. right? They're only defined in the dictionary. So clearly, every time
they're not really even defined in the dictionary.
No, I know, but in principle, they're defined in the dictionary. But it's all just circular,
according to dictionary
definitions.
Makers, according to dictionary sellers, they're defined in the
Okay,
dictionary.
but so clearly, we should include the dictionary entry for every word we say every time we say it. Right? That's great for a language learner, but for somebody who gains proficiency in the language, you don't want to log a dictionary with you all the time. And I don't need this anymore. And at some point, you have to stand on your own feet. Can't just define everything from basics all the time. What was that talk by Guy Steele, where he starts off his talk? Yeah, growing a language, right?
Yeah.
It's painful. If you were to start every talk, every paper, everything you do, every program,
defining
growing things, everything from like some bare bones vocabulary, we make an assumption about the reader.
It's a fair point, and it might be I'm just still haven't grown over my bias of against maybe it's just the glyph that's used for a top or something.
That is an unfortunate pairing that
makes it look noisy and stuff.
Yes, on that front, maybe
this is an experiment I should do, is force myself to.
I think the interesting thing is that, like, I also agree that, like, this is a bit noisy, but my thought is not that, like, tacit is the problem. My thought is that, like, wouldn't it be great if there was a glyph for, the upper triangular matrix, so if you could if there was a higher order function or an operator that if you passed it less, it would give you that matrix, and then, like, it completely collapses like 6 glyphs into one. And also, too, we're technically repeating the prefix. So, like, I'm not saying there should be a glyph for is prefix, but, like, my thought is there a way to, like, contort this in order to only have those 3 glyphs once?
Marshall's what is a primitive post, his document in BQN, because that's kind of what you're speaking to there is.
Well, I mean, I find myself liking 𝗏𝗏𝗡𝗨 when I'm just, like, solving these trivial problems the most, because, like, whenever you want a glyph, it's usually there. And I don't actually think 𝗏𝗏𝗡𝗨 has a upper triangular matrix glyph.
But Iverson notation had that, if I remember right.
Did it?
Really?
Yeah.
There we go. Let's bring it back. Let's make APL great again.
Make APL glyph again.
If I remember right, it had like these.
I mean, clearly,
these symbols that were like little squares with dots in the corners and slashes, which.
I mean, it's a fairly common technique, right? In APL land.
So look at this over here. Maybe I should open up just this frame here.
Oh, special matrices.
Yeah.
Oh, yeah.
And
can we find that? Is the Unicode upper?
No, I'm not sure if they had that, but here.
Yeah. Of course there is. Come on now. I found the upper right.
See, look at this. So these upper left triangle, upper right triangle, lower left, lower right. And if I remember right, there are a bunch more that are defined that, like, if there's a slash going through them, then it includes the diagonal. That's
Madeline, get on it. There's the glyphs.
But that's the thing, is, like,
but then
I think so often, like, the optimal or ideal solution in array languages is so strongly informed by the glyphs that you have access to. Like, and, like, that sounds like an obvious statement, but when you're switching between array languages and, it takes 4 or 5 glyphs to spell something versus a single glyph, like, and then potentially there's a 2 glyph way to spell it in the language where it was 5 or 6 to spell that thing that was a glyph, like, that affects, like, the way I want to spell something, especially if, like, performance is not a concern, right?
Well, I was going to ask Adam with the longest APL experience about the time before key, which is before I even joined Dialogue or knew anything about APL.
Yeah.
But considering what it is and what it does and how it's used, it it's one of those things that boggles the mind a little bit, that people would do things before. And that was what
before key.
Like
people did things
product,
before nested arrays.
match each. Yeah.
Yeah. So outer product, yes, but reluctantly, because its performance would be
obviously
dangerous, right?
Yeah.
So you want to do whatever you can to avoid that. But writing,
and what, everyone would just walk around with a little group by operator or something they would use?
Not necessarily, but I think
direct.
there were, for things that were critical, people would write some bespoke code. Right? So even now, key has performance issues in the general case, but in certain specific cases, it's good. And that sort of comes back to the same thing. If you know what exactly your problem is, you can write some bespoke code that's really, really good and fast and simpler than what it needs to be in general. So I think people did that more, and the same thing goes to the Boolean techniques. Right? You can now we have fancy things like pairwise application and we can
that always gets me in the introductory APL tutorials. In a good number of them, it introduces pairwise difference as a one drop minus the neg1 drop. Even though for quite a while pairwise difference as a windowed reduction has existed.
Yeah.
And yet they always still seem to introduce it that way. I guess because that's what you'll see in real code.
Yeah. I think that's true. I think that's a lot of it's just legacy, that and the pairwise thing wasn't introduced until later, so people just get stuck with that. I mean, Dialog has had tally since version 14 together with key. Nevertheless, people write the first of the shape all the time, or even one pick shape.
Creatures
so
of habit.
Yeah, people tend, it works, right? It doesn't, if mostly.
Yeah, it doesn't even really cost.
I think yeah, people wrote up more bespoke code like this. There's a comment here in the chat saying spelling things with more glyphs can give you insight into the implementation of algorithms. Yes, I think that's true. Like how we wrote earlier, each in terms of ranked and open, as it goes, disclose and enclose, I think gives you more insight into what's actually happening. I think it's a good thing to try to model more complicated primitives in terms of simpler primitives to get an insight in.
There's a good post by Roger Huey about the inner product and the rank operator, and doing a certain spelling of inner product using reductions and the rank operator gave him a way to implement in C that was better than what they'd been doing before.
Oh, interesting.
I wonder if I can dig that up somewhere.
Yeah, I think you can also understand some of the notation better. So a lot of these newer APLs have rationalized the outer product to be a monadic operator, but there's a reason why it looks like it's a dyadic operator with some weird left operand. And that's because there's actually a relationship between outer product and inner product. Right. So if we took 1, 2, 3 plus dot times 10, 20, 30, we got 140. And so this is 1 times 10 plus 2 times 20 plus 3 times 30, and then add it together. But so the outer product, like this, you can actually see it here. So 1 times 10, 2 times 20, 3 times 30. So if we apply the diagonal, which we can do, in this case, it's not really important what the diagonal is, but this is the diagonal, and then we sum it. Okay. So the inner product plus the times is the plus function applied over the diagonal. It's the plus function reduced over the diagonal of this outer product. And if we don't do that part, then obviously we get the outer product. Right. So let's write a model sort of of the outer not of the outer or inner product of the dot. So we're going to write it. So we can define later what actually the outer product does, but let's just say that that is a given thing. So we have the outer is alpha j dot alpha omega. Right, write it out fully. And then we check. Sorry, that's wrong. It's the right operand. And then we check if some null function is equal. So let's just use 0 for now. So if 0 matches, or we can even say, just look at the name class, right? So it's 4D quad ATX of alpha alpha. So this gives us the name class, which let's say is going to be 3 if it's a function, it's 2 if it's an array. So if it's 2, so if it's a 0 or any other value actually, then we just return outer. Otherwise, we do, and this will only work on matrices, but it doesn't really matter. We do the left function reduction over the diagonal of outer. So now we can write 1, 2, 3, and then 0. Yeah, that's fine actually. Dot times 10, 20, 30. It's the outer product, and the inner product is this. So if we see the 0 here as a sort of null function, meaning if you have an operation called the reduce over diagonal, so you do an alpha alpha reduce over diagonal, but alpha alpha is a null function, so we do a null reduce over diagonal. That means don't actually do any reducing over diagonal. Then we just get the outer product. So originally j wasn't used as bind and the composition at all. It was only for this. So j was even called nil, I think. So it was just a nil dot times. I mean, don't do that reduction over the diagonal thing. Skip that step. It's a placeholder for a null function. And now they're consistent, right? And now it makes sense. If you have a null function, then you don't do it. And this concept was later extended to other operators as well, but they never found their way into mainstream APL, including dialog APL. So for example, we have the power operator, which keeps applying a function until something holds true, usually a fixed point, but it could be anything, right? It could be a greater than, could be something external, some custom tests on the successive iterations. So until this condition holds true, and if you use the nil function, then it's forever. So that's the fixed point. Or we could say it has a number. You do it 5 times, right? But nil means just keep going forever. That wasn't implemented because
that was written as an option for fixed point.
Yeah, this was how you'd write it. I think they didn't even have a function. I think it was just originally a number and then fixed point. And that this means there's no particular number. It's not even infinity isn't really true either. That's what J uses, but it's not infinite times. It's until it's stable. It's until it doesn't make a difference anymore. And I think there were other ideas for operators having slots unoccupied in. So I can't quite think of what they would be, but I think we could look them up. So sometimes I think decomposing things into simpler primitives could sort of give you insights about how things work, how they're connected to each other. And if you replace that outer product notation with some other notation, just another operator, then you lose the connection between the inner and outer products. There's a reason why they're named like that, inner and outer products, because they're really related. They're both products of a sort. Anyway, did we look? We didn't even look at other ways of solving this, because now we did the beginning and end thing. Another way we did it with the find. Another way we could do it is taking a prefix of a length, but I still get pretty dirty. you still have array here. So we still need an outer product, but then we still need the masking. All of that we still need. In principle, we could do something like we could get we could save on the computation by computing the combinations table. And then only applying those. So I think we have got let's go 𝗔𝗏. So 𝗔𝗏 3. Oh, that's not right. Do a 𝗏 3 or something like that.
No, you're right. It is a number. Oh, no, 𝗔𝗏's dyadic. 𝗡𝗏 is the monadic one.
Oh, because we want to take. Okay, we want to do how many ways we can be two out of 3. Yeah. Okay. Yeah. So it's the same syntax as the exclamation point, right? That's counting how many there are, and this one is telling you what they are.
Yeah.
Right. So these are all the ones we need to test. Right? So if we got array over here, there are only 4, and we need to choose 2 at a time. So these are all the different combinations we need to test. But that's not really. We do need the ordering, as long as they're unique, right? Because it could be one or the other. So I think actually we need 𝗡𝗏 permutations. But that only gives us.
Yeah, I think I was playing with something to generate combinations of things, and no, yeah, exactly. You basically need to do like a both. You want all the permutations.
Yeah, this is where we need 𝗦𝗛𝗢𝗪's 2000's double exclamation point operator that allows you to specify exactly. Yeah, it has like a compound operand or something that allows you to say like, do you put the balls back again after you use them, and does the ordering matter, and all those. There's like the 6-fold way or some of doing things. 12-fold. I can't really remember how it is. But we could do this and its reverse, right? That just makes sure.
In the case of 2 and 4, that is definitely sufficient. In general, you do you take your 𝗔𝗏 and then you get the 𝗡𝗏 of that length, and then you do basically a row-wise outer product where you take all of the combinations, and then you're probably going to get a bunch of duplicates as a result of that. So
but why can't we just do this?
No, in this case you can just do this because there's only 2.
Sorry.
But in general,
that's what I mean. Yeah.
The reverse.
In our case, there will only ever be 2, right?
Exactly. Yeah.
So these are all the different possibilities, and there can't be any duplicates because 𝗔𝗏 doesn't care about the ordering. So therefore, they will always be sorted, and then they never overlap with themselves. So these are all the ones we need to check. Okay. So now, if we take array and do this, so these are all the pairs that we need to check. And then we just need, we don't have our function anymore, but we can just define that, right? So we can say the prefix and the suffix, and we just need to check whether that's the case for each one of them. And then we ask, are there any? You still with me, Connor?
Yeah, I'm still here. I'm just watching, enjoying, It's like,
so we can write this.
Monday Night Football.
And then...
Except I don't watch football. I watch people coding APL.
Here we go. So this, I think we have the problem of the duplicates, though. Like if we say ab and ab. Oh, no.
No, because why? Because the 𝗔𝗏 doesn't give you with itself. Yeah, there's no duplicate indices in that matrix, is there? There's no 1, 2,
this
2.
This doesn't care, right? So
yeah, it doesn't give you 1, 1, and 2, 2. So
no, but why doesn't this? Oh, we don't know because we want to count them. That's the problem. That's my mistake here.
Oh, right.
I did an or. Yeah. So this will give us 2. So we need to do unique first.
Oh, sorry. Yeah, I'm catching up.
Which I guess we can do that on the. Well, there will never be any duplicates in here, and we don't know what they are. We need to sort of take the uniques before we even start, right? So I think we can just do that. Did you make a mistake here?
Yeah, they don't have an example, do they, where there are different ones, but two of them are the same.
What mistake did I make here? What?
You
Excuse 2. And if I do this, we get a nonsense result. Let's look at that. What's actually happening here? Maybe 𝗔𝗏 is not happy when it's 1. There's only 1.
Oh, it's not. It's a stranding. You got a inclusive simple as well, do you?
No, that should be fine. Oh, that's the problem. How do you take 2
from 1?
From 1.
Oh.
That's the problem. So, I mean, we could just throw in the unique here. And it's slightly wasteful, but too bad. Which means we can also throw the unique in so we don't have to compare the values themselves. We can compare in here. So what actually happens here? 2, 1, and 1. The problem is that they are the same.
Yeah, but the indices, the 𝗔𝗏 doesn't tell you that.
Yeah, no, they're not. It doesn't know.
It doesn't know. Oh, so you do have to do it outside this, actually.
Yeah, I think
you can't apply the unique to the indices. Yeah.
Okay, so this is another solution. That's sort of neat. Get rid of that here. But of course, it relies on a bunch of code in 𝗔𝗏.
Yeah. I was gonna say it's got a big fat dependency and a big fat loopy nested dependency.
It looks like there are any loops, but they are, because we'd actually taken this giant function and actually it's this one, I think, and reducing over a whole bunch of things. So that's actually just it's iterative.
Mm-hmm.
But it might still be, it will still be faster, I believe.
But it's because it's not doing an outer product.
Yeah.
Well, yeah, I think there's going to be a crossover point.
There'll be a point.
Early on, the outer product is probably going to be faster, just because that's optimized.
Yeah. We could, remind you, by the way, if we go back all the way, it's a long way.
It wouldn't matter.
Here, but the Omnifix, we did a single outer product with Omnifix, but we could actually break out the outer product into these two. Okay, so if we take our whole solution here, it's not going to be shorter, but it might be slightly easier to understand if you do like this.
We got to get a 𝗔𝗏𝗪 on here. You see the comment? Do you know about 𝗏𝗪𝗏𝗪?
Yeah, Oracle's mentioning 𝗔𝗏𝗪𝗏𝗪 is useful for this pattern where you want to ignore self-comparisons.
Yeah, didn't we had such a problem once upon a time on the arraycast where we looked at the sum of the array except for every element. We also want to ignore itself. Anyway, so this is another formulation that's it can exactly fit. Right? We sort of make smaller outer products. These are all the suffixes, and these are all the prefixes, and this is the top right triangle. And this is summation. That's step by step. Roger Huey said that writing things tacitly requires greater discipline to keep your code digestible. Okay. So what is 𝗔𝗏𝗏𝗪𝗏𝗪 outfix?
And just a heads up, I have to leave it 5 minutes from now, so we gotta
Okay, so we should.
hard stop then. But yeah, maybe the last thing we can do is look at the. Well, like we mentioned at the beginning, we're looking to build out our panel. So hopefully we will be adding a J
Why when
expert.
Omnifix removed? Omnifix dependent X. So yeah, we want the outer two. But I don't. Yeah, this sort of thing. But I'm not really sure how you'd use it like this. It's not really my forte here.
Prefixes of the flip.
So what was the array we had over here?
Well, let's see an example.
Full solution of sorts. It's J, so it won't win any brevity or was. Okay. But I'm not sure what to write because like okay, so we want 2. But I'm not even sure what the negative thing is. Successive password
One
lists.
is for like sliding window and one is for chunks.
Oh yeah, but
Mm.
how does that help us here? I mean,
No, this is infix. This is not outfix, right?
these are all the okay. So we got something here in the chat. Let's do this in the array. Okay, I see. So it's just for the pairing. Right. So it's using this thing that we had before with the outfix. All the elements with single element removed, right? That's what it's using here.
Mm.
And then we are pairing them up, but we still need to go for each one of them and check whether they are prefixes and suffixes. This doesn't solve even though it's called outfix, it doesn't actually solve the problem of prefixes and outfixes. This just solves
the problem
pairing issue.
Yeah, of getting the combinations without the self combination.
Yeah. Oh, there's an array like.
No, that got eaten somehow. If you go post it on.
Yeah. I can't see their, but the people. That's the annoying thing in YouTube. It doesn't tell people when their message got rejected. It just silently eats them. It lets you see them, but nobody else can see it. So
yeah, if you add the link here, Adam can go.
Oh, there's an. Yeah, but it might take time to do that. You have to do a PR, no?
No, it's just a comment.
Oh, it's a comment there. Okay.
No, you just have to hit F5. Hopefully it happens in the next 120 seconds. Otherwise, I'm pulling the plug on the stream.
I should lean on F5.
Or if I had a what do you call it? If I was like Big Brother, I could have some dashboard that shows all the links being created on ArrayBox, but unfortunately I don't have that, so
it's not there. I mean, with there might be clear. It has find, so we can actually do the same thing. Right? J has find.
Sure, can you do it in 30 seconds?
No, but I can show the principle. I think it's called like E dot. So if we say A B, and then they will find it there, right? That thing, and then we need the first of that, etc. Right, and so that will be the same thing. It's exactly like it's just translation character for character, basically, of the APL code. So we'll leave it as an exercise to the viewer. to figure out how to do that. Okay, Connor,
All
you
right.
want to round this up?
Yeah. I think someone did just post. I guess maybe there's a hack that if you there's this like what looks like a Mandarin symbol for when, which is language. If you put something like that, it enables you to like post the array language. I don't know what that hack is, but or maybe we can see it, but the other users can't see it.
I'm not seeing it. So
Oh, there we got something.
Oh, I see. So it says there's a J1 liner shows up afterwards if you choose show all messages in the chat filter. All right. Well, we'll figure that out. Maybe there's a setting on these live streams where I can just say allow all spam. And,
yeah. So
we'll moderate ourselves.
Okay,
Sure.
so here we have the finding thing, and this is an or. No, I'm not sure whether we do it first there, but okay. Oh yeah, it's just finding if there's a. I don't think this is right, but I'm not entirely sure. Because this looks to me like it's an or reduction atop this, and I think it has to be a first of that instead. That's my feeling, at least.
All right. Well, in the future we'll have a J Pro, and so we'll never find ourselves in this J pickle. And as we mentioned at the top, reach out to us at contact at 𝗟𝗡𝗪cast. Boy, oh boy. I guess you have to do it for 100 episodes before you can nail it like Bob did every time. Contact at 𝗟𝗡𝗪cast.com. And we'll be monitoring, looking for your guys' emails. And with that, we will say,
Happy array
Array
programming.
programming.
Crushed it.